Hello everybody, Bill Sky the COBOL guy with another video in my series of COBOL videos. And what this video is going to be about is after you've defined your data, how can you display it? How can you make it look nice? How can you add a sign, a dollar sign, a currency symbol, decimal points, things like that. So that's what we're going to look at today. So let's get right into coding. Okay, so I have my Linux up here and running, and if you're using WSL or if you're using any other operating system, this all works the same. And I'm going to go into my COBOL projects, and I created a display data project. So let's go ahead and edit that, and it's just the template that I made available to everybody. And so I think the first thing I want to do is I want to display some data. And actually, I want to create some data variables. So what I'm going to do is I'm going to come down here, and I don't know, I'm going to just create a couple of variables, comp1 var1, and I'm going to make that a usage is comp1, and I'm going to say value is 123.4.5. Let's do another one, comp2 var2, not sure why I'm calling it that, but let's do that. And let's make this one usage is comp2. Oh, I see why I did it. And value is 36 let's say 987.648. Okay, so just more decimal points than the previous one. Okay. So that's creating our 77 level data. Now let's go down and just display it. And you're going to see why you might want to do something to make it look better. So I'm going to say display comp1 var1. I'm going to say display comp2 var2. Let's go ahead and save. And I'm going to renumber it, reload it, and there we go. And now let's go ahead and build it with a make. All right, so let's take a look what it looks like. So I'm going to move this over here so it's easier to get to. Okay, well, I mean, that's okay. You can see the data there, but COBOL is a business-oriented language. I mean, it's in the name COBOL. And when you're looking at your bank statement, when you're looking at any kind of a business document, you don't want the decimal points to be off so far. And also, you might want the decimal points or the fractional part to have the same number of decimal points or the same number of decimal digits or fractional digits. So I think we should go ahead and do something about that. I think we should go ahead and fix that. So one way of fixing it is I'm going to create a variable, and I'm going to just call this print comp. And what I'm going to do here is I'm going to give it a pick, and I'm going to say plus 1234 dot 12345. Okay? Now, this right here is not a variable that you can add stuff to. Let me go ahead and say value is 0. And then down here, I'm going to say add 1 to print comp. Let's save and build that and see what we get. We immediately get an error. Is that even though this is supposed to contain numbers, you really can't do math on it. And that's why we have comp1, comp2, all the way through comp, I believe it's 5. But you use those comp variables to put the data in, do mathematics on it, compute with it, and then you move that data to a variable that actually is used for displaying data. So let's go ahead and delete this. And in its place, I'm going to say move comp1 var1 to print comp. I'm going to display print comp. And then I'm going to move comp2 var2 to print comp and display print comp. Let's go ahead and build that. And now let's run it. So this is the old way of doing it without the display variable, and this is the new way of doing it. So you can see that both numbers have the same number of whole digits, both numbers have the same number of fractional digits. So it's getting better. It's getting a lot better. We're not quite there yet, but we're getting there. One of the problems with this one, though, is that we have a bunch of leading zeros. Okay, we may not want to do that. So one way to do that is to come into our pick right here, and I'm going to put in, let me see, pick plus, and instead of 9s, I'm going to put in Z3. Z3, that is a zero suppression. So I'm going to put Z3 and then 9. I always want to have at least one 0 in front of the decimal point. That's why I have the 9 there. But the other three digits, I want them to be 0 suppressed. So let's go ahead and build that. And now let's run it. All right, that looks a lot better, right? We don't have any zeros in front. If the number was like 0.50, it would be 0.50. So that's looking a lot better, but we can do even better than that. Now let's go ahead and make that even better. Let's move the plus sign over to right up against the 3, which would be a nice feature. But before that, let's say we're doing currency values. Well, there's a couple of problems with currency values. First of all, currency values don't have 5 decimal points. They normally only have 2. And instead of a plus, we normally have a dollar sign. So let's go ahead and put a dollar sign in front and then change the decimal points to 2. Let's go ahead and build it. Let's take a look at what it looks like. Whoa, so that's looking a lot better. It looks like we actually have some good data there. Now the dollar sign is right up against it, so we might want to change this to, let's say, you have to look at your data. Are you going to have data with more than 4 whole digits or not? But so let's go ahead and put a $Z4 there. Let's make it again. Okay, so that's looking good. That's looking really, really good. Now the other thing that we can do here is, instead of, notice the dollar is way out here. You might want to have the dollar right next to the 36. So instead of Z4, I'm just going to say $4. Dollar plus, those are all 0 suppression as well. Let's go ahead and see what that looks like. All right, good. So we're getting even closer there. So you can see the dollar right there. Now you don't have a space in between, so I guess what you could do is you could say $3 Z maybe. Let's see how that looks. May not build. Yep. So there are certain rules that you can't do. You can't put a Z. What does this say? It says error, a Z or an asterisk which is before the decimal point cannot follow a floating currency symbol string. So you do have some rules that you have to go by here. Now you can do the same thing with the plus sign. So I'm going to put a plus. Let's say you're not dealing with currency. Let's say we are dealing with something, I don't know, scientific. So I'm going to go ahead and make that. And so you can see how the plus sign moves back and forth depending upon your pick. Let's go ahead and make that a 4. And this is really the best way to get to know this. If you notice, the first time on this one, I only had a +3, so we lost that 1,000 value there. So it's always a good idea to try these things out and see what you get as you do things. So it's a really good idea to test these things out. Remember, you've got a number of different formatting characters there. You've got the dollar, you've got the plus or the minus. You've got the Z for 0 suppression. Those are all different formatting characters. If you just use a 9, it's not going to 0 suppress anything. And you also have the period. If you notice, we put a period there. What happens if we get rid of that period? What does it look like now? So the period's pretty important. We completely lost the fractional part. One thing about this, though, is let's say we wanted to display things with 2 decimal points as currency. And let's just go ahead and revisit this. So you can see we have 1, 2, 3, 4, 5. Well, actually, let's look at what the number is. Yeah, 1, 2, 3.5. That looks good. 36.9876. Well, that happens to have rounded correctly, but let's put 99 there instead of 48. And some of you may already know where I'm going here. So you can see it's 9876, but let's say we wanted to round it up. How do you round it up? Well, the IBM COBOL compiler has this function called round, but the GNU COBOL does not. So if I wanted to round that up, I would have to do a few little things here. What I would do is instead of a move, probably what I would do is I would say compute comp1 var1 equals, or no, I would want to say print comp equals comp1 var1 plus, and depending upon how many decimal digits, in this case we want to have, well, how many do we want to have? Let me see, we have 6 there, so 1, 2, 3, 4, 5, 6, so we'll do that. And then we can do the same thing here. Compute print comp equals comp2 var2 plus, and that actually has 6. Well, the first one only had 2, so let's go ahead and change this to, oh, that's okay. Let's leave it there. And just do the compute. So let's go ahead and build that, and now let's run it. Okay, so you can see the difference right here. Without the rounding up, you've got 0.9876. With the rounding up, you have 0.9877. So if you're dealing with decimal points, let's say we want to go ahead and just put 2 decimals here in our pick. Then we want to round up to the nearest 2 on both of these. And it'll look like currency. Let's go, and we already have the dollar there, so that's good. Let's run it. And so you can see it's now 99 instead of 0.9877. So you're going to have to do some rounding to play around with the numbers to make sure they look good. And that's what it's all about. It's all about what the numbers look, how they look good. One other thing I wanted to show you is I want to build this as an IBM, using IBM COBOL. And we actually have an error here. It says on line 23. Okay, on line 23, I don't think for a pick we can put a value is. So let's go ahead and save and build that now. Yep, that was it. Let's take a look at the IBM compiler. Now we're going to specifically be looking at these display comp1 and comp2. And you can see that the IBM compiler even makes it worse. It just makes it worse. Okay, it's scientific notation, but you also need to make sure that you set up your display variables in such a way to make them look good. Now, one thing though about this is that these numbers aren't right. They don't look right. So these values I find this interesting on the x86-64 IBM compiler, value is really doesn't do anything with those. So if you actually want to put some data in there, you have to say move into comp1 var1. Actually, let's move 1, 2, 3, 4.5 to comp1 var1, and then move 36.987699 to comp2 var2 to get some data in there. And let's go ahead and make it. Oh, assembler language again. And now we've got actual data in there. So for some reason with comp1 and comp2, the IBM compiler doesn't allow us to put a value in there using the value is. It compiled, but it just didn't seem to work. So we went ahead and moved the data in that way, and then we got the data that we were looking for. Now the dollar, the plus, all of these special formatting characters, these all work great in both compilers. There's one other thing I wanted to show you, that there is a V specifier that you can put in there. And what that is an implicit decimal point. It doesn't actually do the work of a decimal point. It doesn't actually print the decimal point. So you can see it's 1, 2, 3, 4. It should be 0.50, but it just shows 50. So I haven't used these very much actually in the newer versions of the COBOL compilers. So if you want to display something, it's always a good idea of having a variable like this to print the decimal point. Let's build it and make sure that everything still looks good, and it still does. So there you go. There's an introduction to displaying data, formatting your data in such a way so it can be displayed well, whether it be on a report or whether it be on the screen. And I hope to see you at the next video.